Hello everyone, which right now is nobody, because nobody watched it last time. But we're at episode 2 of AWS Cloud Quest, where we're going to be learning about the cloud while we play a video game like a nerd. Here we go. Starting our game. Last episode, we got, I think we did 3 down yesterday. So we're aiming for at least 3 today. And here we are. I'm a level 4. And I'm entering Cloud, and right off the bat, we got some footprints. So, let me take a happy little stroll. I learned something yesterday. Boom! Wait. Why does left shift work? But either way, we got a hoverboard. So, check me out. Alright. And, is this a deer? What does Amazon EC2 provide in the cloud that is secure and resizable? Well, EC2 is computing. I think that's all we need to know. Oh, sorry. For those of you who might not be able to read while you're listening to this, let me get in the habit. What does EC2 provide in the cloud that is secure and resizable? Storage capacity, database tables, compute capacity, or backup volumes. We're going compute capacity. Bucky is becoming more friendly. Well, I guess he's a deer. Answer 2 more quizzes, and he will become your friend. We got some more footprints. We're gonna do a couple. Oh, this cat. This is a cat that doesn't like me. Looking for a pet. Sorry, I don't belong to anyone. And this guy, look at this giraffe. Same thing. Just too bougie for me. Is this a horse? This looks like a horse. A developer would like to set up a simple, low-cost, static website that delivers HTML, JavaScript, images, video, and other files to visitors. Which action should the developer take? Okay. A. Create an Amazon S3 bucket and then enable static website hosting. B. Set up an Amazon EC2 instance and then install WordPress on the instance. C. Use Amazon Lightsail to launch and manage a web server. D. Launch AWS Elastic Beanstalk to configure a web application. All right, first of all, it's not really a web application, it's a static website. So we're not going to use Elastic Beanstalk. Lightsail is used for lightweight tasks, but I'm not so sure on that one. Set up an Amazon EC2 instance and then install WordPress. I've never really heard of installing WordPress. That's probably a thing, but it seems like overkill. I think the correct answer is create an Amazon S3 bucket and then enable static website hosting. That seems to be one of the things they're most proud of when it comes to Amazon S3. Boom. Peanut the horse. Answer 5 more quizzes correctly, and this pet will become your friend. I say hell yeah to Peanut. Alright, one more, and then we gotta get to some real work. I love this hoverboard. This is crazy. Why are you taking me so far away? Alright, there we go. Let's go this way. More footprints. And I'm zooming. Which way am I? Oh, is it this one by the bridge? There is a potential pet by the bridge. Ooh, it's the bird. I think I had this guy yesterday. What is an example of an Amazon EC2 instance type? We got A, M5.large, B, ARM64, C, web_server, D, bucket. Immediately, bucket has to do with S3. That's the only time you'll ever hear the word bucket when it comes to AWS. C, web server. I don't think it's that simple. I don't know. ARM64. You know, I've heard that term in other. I don't think that's right. I think that's a different term, but it is a term. M5 large, on the other hand, sounds like the T3 micro we were using yesterday. Actually, we might have made it M5 large yesterday. We might have changed an instance type. That's one of the 3 scenarios we had yesterday. Well done. Seagull is becoming more friendly. Oh yeah, I totally talked. Ooh, one more quiz, and I got Seagull as a pet. Man, more footprints. No, I said let's get to it. All right, so we could either do networking concepts or cloud economics. You know, I'm a businessman, suit and tie, all about my business. And we're right there anyway, so let's go. All right, okay. How do we, whoa, I did not mean to zoom out. All right, how do I fucking move? What do you mean lot area? All right, can I just click on this and go? Okay. Well, usually we drive there, but I suppose we're being lazy today. Hey there, thanks for coming. I want to set up my surf shop in the cloud, and I need some help. I'm the right guy, man. No problem, how can I help? My biggest concern is cost. I noticed my online store gets more traffic during the day than at night. I think I could reduce my servers from 4 to 2 during nighttime hours. Yes, that's a key benefit of cloud computing. You only pay for what you use. When you don't need resources, you can turn them off and stop paying for them. Great, before I plan my move to AWS, I need to figure out the costs. But I don't know where to start. Should I just copy my current setup? How do I find AWS hardware that matches what I'm using now? Yes, you can match your current setup. And AWS provides guides to help you do this. However, we often find that businesses buy more hardware than they need when running their own systems, trying to plan for future growth. So I might be able to use less powerful systems. How can I do that safely? What happens if I need more power than expected? Because AWS services can quickly grow or shrink with your needs, you don't need to buy extra capacity just in case. Start with what you need right now and adjust as you go. That sounds good. Can you show me how to figure out what this will cost? I want to make sure I'm saving money. Of course, I'll use AWS Pricing Calculator to work out the costs and send you a link you can review. I'm looking forward to seeing it. So we're using the AWS Pricing Calculator to calculate the cost of an Amazon EC2 web server. And then I'm going to share it with Jose here. All right. Cloud economics create a cost estimate for a varying Amazon EC2 architecture based on peak demand. AWS Pricing Calculator creates estimates for AWS use cases, providing solution modeling, price point exploration, and detailed cost calculation review before implementation. On AWS, users can take control of costs and continuously optimize spending so that they only pay for the resources they actually need. Using fixed resources as demand fluctuates can lead to overburdened servers during high demand periods, potentially resulting in degraded customer service. During low demand periods, unused computing capacity creates cost inefficiencies. AWS resources provide elasticity, offering on-demand provisioning that aligns infrastructure capacity with actual demand. The alignment of infrastructure to demand is achieved through scaling. During increased demand, services can scale out horizontally by adding more resources, such as EC2 instances, to the infrastructure. As demand decreases, systems can scale down by reducing the number of active resources. AWS Pricing Calculator generates no-commitment estimates, helping users explore service options, plan budgets, identify cost-saving opportunities, and make informed architectural decisions. Cool. So here's our pictures. This guy has traffic, and we're calculating what we need and how much it'll cost. Seems very fucking simple. In this practice lab, you will... Oh man, I'm not even full screen. Boom. All right, hopefully that didn't change anything for you guys. We're waiting. We're waiting. Okay. I think we're good. Create logical pricing groups. Create an estimate for the EC2 instance usage. Oh my God. All right, let's go. Let's start it. I should have hit the start button way earlier. Now we gotta wait a minute. We have to wait a minute. Oh no. Wait. Okay. Uses the calculator. Type calculator.aws and press enter. On the top breadcrumb menu. What the fuck is a breadcrumb menu? Anybody heard of that? That's interesting. Click my estimate. Go to the next step. All right. Calculator.aws. Let's do this. In a new... Okay. The browser itself. So we're on AWS price calculator. We're gonna create an estimate. I think. I don't fucking know. Click my estimate. Go to the next step. Now we're in my estimate. Click create group. Name it web servers. Here's the create group button. Web servers. And create group. Now we've created a pricing group. Add a service. Find EC2. Web server estimate. Add service. Is this where we search? EC2? Sure. Okay. Description. Web server estimates. I think that's what we were naming it. Web server estimates. Estimate. Boop. Location. Choose US East, North Virginia. All right. In the EC2 specification section, for tenancy, choose shared instances. Okay. By default, EC2 instances run on shared tenancy hardware, meaning that multiple AWS accounts might share the same physical hardware. Choosing a dedicated option increases instance pricing. Choose Linux for the operating system. You can bring your own license if you want to use a different operating system. For workloads, review each usage type. You can click each usage type for details. Go to the next step. Choose the daily spike traffic workload type. Here we go. Now we're getting into some real stuff. Daily spike traffic workload. Now we're gonna simulate a spike pattern for the workload that this web server is gonna have. All 7 days, Sunday through Saturday. This guy doesn't take weekends off. Surfers are just buying stuff every day, I guess. Baseline is 2, peak is 4. 8 hours of peak. That's crazy. 2, 4, 8 hours, 0 minutes. That's a lot of peak time. Right-sizing instances is a key cost optimization strategy on AWS. This process involves analyzing your instance resources and find opportunities where you can reduce size capacity without impacting performance. In the EC2 instances section, for any instance family, under vCPUs, choose 2. Any instance family, but I'm very confused. So an instance that has 2 virtual CPUs in it, I guess. We're gonna choose 4 gigabytes of data and any network performance. More. Okay, cool. We're going to do a T3 medium as our instance type for EC2. We're doing a lot of EC2 in this basic course. It seems like EC2 is the main driver here. I mean, it is the main service, in my opinion so far. T3 medium, right? Am I tripping? All right, T3 medium. In the payment option, choose on demand. You can pay, no long-term commitments. Review the settings. You can save money if you buy it for longer, but we're going on demand. Maximize flexibility. Bam. And we could look at all this stuff, but I'm not going to. Save and add service. Successfully added. Oh my god. Review the I hope we're not changing anything because I already added this. Show calculations. Click the estimated workload hour. In the pop-up box in the workload hours per month section, review to compare how instances are charged daily. So that's what we're getting from that, is that instances are charged daily. Note that instances 1 and 2 are charged for 24 hours per day, while instances 3 and 4 are only charged for 8 hours a day. Under utilization, review, click close, go to the next step. Oh my god, we have to edit this. How do we do this? All right, we're not adding a service. We're going to. That's just changing the name, right? No. Okay, cool. All right, so let's scroll back down. Where EBS, we're going to choose general purpose solid state drive, general purpose 3. So EBS is our storage. Oh, it's already there. Okay. So that's the storage we're going to use. General purpose SSD. Input output operations per second, IOPS, we're going to do 30. 30 input output operations per second. Storage amount type 10 gigabytes. Next step. Wait. that wasn't a thing. This was our thing, right? Okay. We're going to do weekly snapshots, and we're going to do one snapshot. So weekly, and yeah, GB 1. I don't know why we even entered this lab right here. It feels strange to me that we haven't been using it. Data transfer from internet, 1 terabyte per month. Data transfer, internet, 1 terabyte per month. All right. Outbound is going to be internet, 100 gigabytes per month. Internet, 100 gigabytes per month. Click to expand show calculations. We're going to show our calculations right here. Wow. Monthly cost of $9 US. Review to see the rates, how it's calculated. Click view summary. I don't see that button. Oh, save and add service. Skip that. So we're gonna update, obviously. No thanks. Where do I see view summary? Estimate summary? I don't see this button, and I don't know what I did wrong. Save and add service, my estimate, add service, add service. Okay, here we go. View summary. Oh, that's okay. Fancy that. Now we're gonna add some support in this pricing calculator. AWS support helps with technical issues and additional guidance to operate infrastructures in the AWS Cloud. Oh, we're just going to cancel. So basically, we're just seeing that there is a plan if you wanted support for your web server. You can buy it right here, or you can estimate the price right here in the same calculator. All right, we're going to share, agree, copy the link, and that's it. Agree, copy the link, and we're gonna DIY. Change it to a T2 micro. And that's it. So we're gonna go into here, hit the little pencil, and change our EC2 instance type. Why was this? Oh, I see. So we're a T3 medium right now. We want a T2 micro. So let's just search T2.micro. Oh, okay. It might not have 2 virtual CPUs, and that's why I was. Yeah, okay. T2 micro. Here we go. There's one virtual CPU on a T2 Micro. Now we're going to update. And we're going to share. Copy. And hopefully, this was a super easy one. Validating. Please validate me. I need validation. You did it. Congrats, dude. No surveys. All right. Now let's go get my reward. Because what would be the point of... What the hell is this guy got going on? Is this what I'm surfing? Am I on one of his surfboards right now? Because that looks like a hoverboard. Alright. Let's see what this dude's got going on. Wow, this all seems so affordable. This is within my budget. All right, I get to pick. Okay, do I pick the lame scooter, the badass bike, or a paper airplane? You know, I'm gonna go paper airplane. And that's what we're riding on. And there's fireworks and everyone's happy, and I leveled up and my player level increased to 6. My builder level increased to 4, whatever that means. Plus 10 Amazon EC2, plus 10 Amazon S3. I didn't do anything with S3. We're using EBS as our storage. I don't know, whatever. Let's do it. Yeah. Oh, and this is where I buy new hoverboards. I mean, I got the paper airplane. I don't see why I'd want anything else. Hey, I'm doing yoga on this shit. How do I zoom in? How do I? Okay. Yeah. All right, enough of that. All right, let's go talk to some animals. Because what else would I do in a suit on a paper airplane flying through a city in the sky? Fuck you, Mr. Giraffe. I want a real pet. Man. And fuck you, Mr. Cat, because I already know what you're going to say. Same shit. And we found an animal. What is it? I didn't even see what it was. Question. Which type of scaling is used when the number of EC2 instances is increased behind a load balancer? All right, so it's either vertical or horizontal. Here's my thinking. Vertical is making something that already exists bigger. Horizontal is adding more of them in a row. Like, you can't stack too many things vertically, right? Like, you can't make it higher if they're all separate pieces. So I'm going to go horizontal because we're increasing the number. And that's I don't even want this guy. This guy's ugly. Racer? Answer 2 more quizzes correctly, and this pet will become your friend. What the? What's going on? Why is my screen red? What the fuck? Is that about to get... Is it this guy? Am I going... My heart is racing. Is this a boss battle? Oh! Shit! What the... Oh, he's attacking me with a quiz. I better get this right or I will die. Question. Which format are Amazon S3 bucket policies and IAM policies written in? JSON, HTML, CSV, or XML? I have a feeling I remember this answer, but give you guys some time to think, because I know you guys are out here studying with me. Now, I don't really know how to describe how I know that I know this answer, other than I just remember it. It's JSON. Woohoo! I got +1 Amazon S3 and +1 IAM. And he didn't. Oh, I killed him! I killed him! I was about to leave towards that other pet, but thankfully I decided it was time. Recertification island. No, I don't need a recertification. I've got no certifications to recertify. Alright. Let me go find this other pet, and then I'll stop fucking around. We can get to another level. But these levels, they do drone on a bit. They do get a little bit boring if I were to just do levels. So, there's my lighthouse that I built. That was the first challenge in episode 1. Hi, lighthouse. Wonder where my house is. Is that a fucking end portal? We're going across the bridge. Oh, there's another boss. Chat, should I? Machine Learning Island. And they got something. Oh, this pet is trying to kill me. Let's do it. You going down. What even is that? Why do we have enemies here? What is true about Amazon S3 pricing? Charges occur per bucket. Charges occur per object. Charges occur per gigabyte. Charges occur per get, put, copy, post, and list request. Charges occur per connection. Select 2. Alright. Let's go at them one at a time. Charges occur per bucket. Buckets can be any size. They can have a million objects in them if they wanted to. That would be stupid. Charges occur per object. Objects can be different sizes. That would also be stupid. Charges occur per gigabyte. That sounds reasonable, right? Charges occur per get, put, copy, post, and list request. That also makes sense, because that's something that has to be computed to have done. Charges occur per connection. Well, you can do many things on one connection. So I don't think that's it. We're going to go with these two. Woohoo! And we did it again. +1 Amazon S3, +1 Cloud Economics. We're leveling up out here, killing these fucking wasps. They do look like wasps. I don't like wasps, so glad I'm killing them. And is this a bear? Hell yeah. What can be changed to scale an Amazon EC2 instance to the demands of a workload? Region, availability zone, DNS, or type? Well, when we're talking about Amazon EC2 instances, DNS just doesn't make any sense whatsoever. So let's get rid of that. And now the other keyword we're talking about is demands and scale. You can't really scale to a region. That's a location. That doesn't help me with my demands. And same goes for availability zone. You can't really scale using availability zones. That has nothing to do with computational power. So type, like we just changed that from an M4 medium to a T2 micro or whatever the fuck we did. That's a type, and now it has less demand on it. We're gonna go type. And Mr. Honey is becoming more friendly. 5 more quizzes for this guy. This guy's bougie. I'm about to get murked. I'm about to get attacked and I'm not even moving. I didn't. My heart was... He snuck up on me. What's up with these? They're everywhere. All right. When I beat you, then we're going to do another level. Which key value pair can be used to describe an Amazon EC2 instance through custom content and metadata? Oh man, so it's not EBS, Elastic Block Storage. That has absolutely nothing to do with what we're talking about. Policies, I think, are different. I think those are actually useful. We're just trying to describe something. I think it's tags, but it could be definitions. I think it's tags. We're gonna go tags. +1 Amazon EC2. Did I read off the answer choices? I hope I did. Anyway. +1 Amazon EC2. And that is enough quizzes to get us going. We're going to go networking concepts now. And while we wait. Are we leaving? We're leaving Machine Learning Island. We're entering Cloud Isle. Oh, there's the pet. Nope. That's so funny. It won't stop trying to drag me. I'm trying to get the pet. Oh, I can click and go? Okay, now we're not. It's the same deer. He's ready to talk again. Which Amazon S3 feature automatically changes data storage tiers based on user specifications? I mean, this has got to be pretty fucking easy, but let's read the answer choices. Amazon SNS notifications. Lifestyle configuration. Amazon S3 Glacier. Event notifications. All right, let's Amazon S3 Glacier is a storage solution. Has absolutely nothing to do with what we're talking about. So, and to the same token, nothing that's going to automatically change my data storage is going to be called a notification. So it's not SNS notifications and it's not event notifications. It's the lifestyle configuration, because as the lifestyle progresses or evolves, whatever, it's going to automatically change. That's the only thing that has anything to do with changing and automatically doing something for you. Boom! Bucky is becoming more friendly. I got one more question on Bucky. All right, let me go to mi telefono and we're going to go networking concepts, baby. Let's get in the pose. We're going to networking concepts. Is his foot in the air? How does he do it? Oh, I did forget. It's not a habit yet. But after each successful mission, we're going to take a health break. Oh, this lag is too crazy for me. I just hope you guys can see me, because I'm not waiting for the camera. 1, 2. You guys at home better be doing this if you got space and time. 5, 6, 8, 9, 10. Oh. All right, and now I can see myself moving the camera. Let's see how good of a job I did. Anyways, who is this? Oh, is this a Karen? Does she have green hair? I'll call her Kristen. Hello, Kristen. Going in the... you can kind of see me. I guess because I'm a circle, that's got to be pretty decent. Oh, man. But do we go scripted mode or do we go AI mode? I think we're going to go scripted mode. We're going to keep it short. We're not going to mess with all that. Welcome to our banking headquarters. I'm so glad you came to help. I'm always happy to help. What can I do for you? We recently migrated our services to the cloud, but we've noticed some connectivity issues with our Amazon EC2 instances and databases. The EC2 instances cannot connect to the internet, and our databases are unable to communicate with our instances. Have you checked your virtual private cloud or VPC settings? In your route tables, you can check that an internet gateway is attached and that the VPC is set to allow outside traffic. Is that complicated? I'm a little concerned. We need these changes to happen immediately. We can't afford to wait too long for network updates. I understand your concerns. Security group and route table modifications are applied immediately. Also, setting up an internet gateway for internet access can be done in minutes. That's great, but how do my engineers create a VPC without internet access? Isn't that included? On AWS, by default, VPCs are not configured with internet connectivity. When you create a new VPC, you have the option to enable internet access for all or part of the VPC. This way, you can customize your network security configuration according to your requirements. Interesting, I'll check out the... Let's go. We're gonna create a routing table and attach an internet gateway, and we're gonna configure a security group. Are we not starting yet? Let's go. We're on the table, on the operating table. Got 7 slides to go through. Here's our picture. We have an internet. That's the internet. Internet gateway, router. Now we're in the VPC. We're in the virtual private cloud. It's going through a public subnet to get to, through a security group to get to a web server, which this little symbol looks like an EC2 instance. Inside of the security group, inside of this public subnet, 10.10.0.0/24. Then that goes through a private subnet, through another security group, to another EC2 instance. This case happens to be a database server. And that subnet is 10.10.2.0/24. All right. This solution demonstrates a network architecture that restricts internet traffic to the designated public AWS resources. The architecture deploys web and database servers within a virtual private cloud, providing a logically isolated network environment in the AWS cloud. A web server with a public IP address resides in a public subnet, enabling internet activity. The web server security group permits HTTP traffic through port 80. The VPC route table directs internet traffic through an internet gateway exclusively to the public subnet. A database server operates in a private subnet isolated from direct internet access through route table configuration. Database connectivity requires security group configuration permitting web server access through port 3306. All right, so port 80 here, port 3306 here to get to the database. 3306. Wonder what port that is. Port 3306 is MySQL. So that's a type of database. Type of relational database, I think. Yes, okay, cool. So that's what's going on here. Everything makes a lot of sense. Time to practice. Oh my God, again, I should have started the fucking lab. Does it give me an option? It does, right? Okay, well, we only have to wait 15 seconds. All right, let's close our last lab, actually. Let's open this. All right, we're gonna make sure that the region is in North Virginia, US East 1. Then we're gonna go to EC2. There, check. EC2. Boom. Click on our instances. We're going to choose the web server. And we're going to copy the public IP address. of that web server. Instances, web server, public IP, that's DNS, public IP. How do I scroll that way? There should be a scroll bar here somewhere. Oh, I'm just going to click on it and copy it here. And we're going to go to that. We're going to go to that public IP address. And according to the lab, it should time out. So we can play the dinosaur game. Return to EC2. All right. Review to confirm the web server instance is still selected. Click the Networking tab. Review the public and private IPv4 addresses. Okay. So we got a public one, 34.206.132.108, and a private one, 10.10.0.10, which is in that private subnet that we discussed earlier. Still trying to load this. That's crazy. Doing its thing. It's not going to work. We already know this. Click the provided ID under subnet ID. Okay, so that'll go to our VPC console. Subnet ID? It did say subnet ID, right? There we go. So we're going to click this, it's going to open, and now we're in a console, the VPC console. And here is our subnet. Select the subnet that starts with network concepts. Click the route table and click the link name. All right. So, boom, route table. Let's make this a little bigger. Okay. Oh no, that's small. Okay, that's it. This is the route table. Very small. And what are we doing? Click the link name that contains web server net subnet 1. Oh, wrong one. I don't see it. Oh, this one? At the very end? Okay, these are our route tables. Next step. Check the box. Click the Routes tab. Review the 2 route table entries. Check the box. Routes. Here's our 2 entries. So it looks like local is set up, and it looks like this destination any is also set up. One route sends local traffic to the local network only. The other route sends all other traffic to the internet through a NAT gateway. Click Edit Routes. We're going to edit these. All right, now we're editing the routes. The CIDR naming convention. Oh man, I forget what that stands for. 0.0.0.0/0 represents all possible IPv4 addresses. :/0 for IPv6. To delete the NAT gateway from the route table, click Remove. So here's our NAT gateway. We're going to remove it. Cool. By removing this route, the instances in the subnet can no longer connect to external services. Then we're going to add a route. our destination is going to be 0.0.0.0. Easy. Target is going to be Internet Gateway. Internet Gateway. I guess that's our Internet Gateway. And then we're going to save our changes. Cool, we created the route. Now we're still on this same routing table. These are the routes of this routing table. Target, you can see that we have a new target. That is true. The subnet is now reachable from the internet because we put it to the Internet Gateway. Return to the Amazon EC2 console in the other browser step. I'm going to close this. Boom. So actually, this should work now. No? Accessible from the internet? No? Maybe not quite yet. Oh, the subnet is now reachable from the internet. We still have to do another step, right? In the Instances section, choose the checkbox to select the web server instance. Click Security. So we're going up. Instances, web server, security. Security groups. Here's our group. We have absolutely no rules except for this one outbound rule that goes to the database. Which that's cool. We don't have an inbound rule. I'm guessing we need an inbound rule. Like allow or HTTP. Nope. I guess that's not what we're doing. Let's see what we're doing. Under security groups, click web server security group. Go to the next step. Here we are in our security group, and this is where we create the rule, I guess. Security group details, inbound rules, edit inbound rules. So we're going to create an inbound rule for the security group. Okay, because we're in the VPC, we're in the public subnet. We configured the internet gateway to allow us into the public subnet. Now we have to find our way into this EC2 instance that is the web server that is protected by a security group. Okay, so remember that little box inside of the big box that is housing our EC2 instance is going to be this security group, and we're going to add a rule probably. HTTP traffic from port 80 source is going to be, let's do anywhere. Do I balls it and say save the rules? Did we just think that we know what we're doing here? All right. Add rule. Choose HTTP anywhere. Cool. Yep. That's what we're doing. Review that an existing outbound rule exists, typo, allowing traffic on port 3306. 3306 is the default port used by my SQL database server. I knew that, bitch. Not really. I had to look it up. We're going to edit our outbound rules, and we're going to add another outbound rule. Because we got to go back to the internet, right? We got to deliver this back to the internet. We can go to our database already. That's fine. But we got to go back to the internet. So, where are we? Outbound rules. Cool. Edit. Add a rule. We're going to go HTTP again. We're going to go to anyone. Anyone is allowed. We're all inclusive here. Yeah, that's what we did. Okay, cool. Review that it's successful. Check the box next to web. Click networking. Copy. Do not click open or the page will not load. In a new browser tab, paste it. Make sure you use HTTP, not HTTPS. A connection should be established. So, fuck all that. We're just going to refresh this page. Nothing? Huh. Okay. We're going to go back to EC2 instances, my web server, details, public, new browser tab. Did I do something wrong? Make sure you use HTTP. HTTP:// nothing, huh? Did I do something wrong? For type, do all traffic. So we're not doing just HTTP. All right, so that was my bad. Let's, we're gonna go back to security. We're gonna go to our security group. That's how we're gonna edit this. Then we're going to edit our outbound rules, and this outbound traffic is gonna be all traffic, anywhere, so that's anywhere, save. Now we try HTTP:// paste. Okay. Not bad. It's checking, but we're here, so we know we did something right. Can't connect to my SQL server. We gotta check the security groups or the access control list on this database right here. All right, let's make sure we're on the right. The connection should display as failed. Go to the next step. Congratulations. Now we have to do it ourselves. We have to fix this. Change the security group rules to allow traffic over port 3306 into the database server. Funny enough, I think we could just figure out how to do that. So we're going to go to EC2 instances. Our database server is what we care about now. Security groups. Outbound rules are looking good. We can send that shit back to anywhere we want to. But inbound rules are not looking so hot. We don't have any, actually. So we're going to add an inbound rule. MySQL 3306. Source is going to be anywhere? No. We want it to go to 10.0.10.0/24. Was that? Let me look at my 10. Oh no, it's 10.10.0.0/24. So let's go and fix that. 10.10.0.0/24. Save the rule. Now we refresh. It's checking again. Connected. Cool. Seems easy enough. So now let's copy this, and then we're going to paste it and validate that we did what we needed to do to configure everything. Okay, database security group name. That's what we're validating. All right, database security group ID, right? That's what we want to copy. You did it! Oh, we did it! This is actually intuitive. I know learning about IT can seem a little daunting at first for me. I have no experience in it, but oh wait, no feedback. But this was actually pretty good. Let's get our reward in a second, but I have to pee, so you guys entertain yourselves in whatever way feels fit for you. God is watching. But don't forget, we just completed a lesson. It's time for some push-ups. Get your fat ass off the chair. Don't even think about skipping this. Our physical health is just as important as our mental health, and they kind of both go together, especially when you get older. Ugh. And I don't want to see any girl push-ups either, but if that's where you're starting, that's where you're starting. As long as we're doing something, we can get there with time. Alright, close out of what we was doing. Let me talk to Kristen and see what our reward is. Thank you for subbing. I'll never kiss you. This is something. Oh, we get to choose between. Oh, this is a city hall. I was like, what the? So we get a nice, classic-looking blue house, a fucking skyscraper with a fountain on some New York shit, or a haunted dungeon of doom. Haunted Dungeon of Doom! Oh shit. You guys probably heard me anyway, that's being loud. Yeah, we got effigies and spikes and tall things to fall off of and kill yourself. We're leveling up the neighborhood, right? Making it a better place for the children and the homeless. Now they have spikes to impale themselves on. Plus 10 Amazon EC2, plus 10 Amazon VPC. That's what I'm talking about, baby. That's what I'm talking about. That's what I'm. And look, this guy has something to say to me. Is this the mayor? Is this Mr. Mayor? No, it's not. It's not Mr. This guy jacked my outfit. Fuck you. I wish this was GTA, bro. These punches. No. I wanted to go. No, I don't actually want to do this. How do I cancel? want to do this. Okay, cool. We're gonna go talk to some animals first. Actually, let's check out our magnificent creation. Look at this. Look at this city hall. What could be more... I mean... Ooh, this is Doofenshmirtz Evil Incorporated. But I can't go in these buildings, so it really doesn't affect me too much. I mean, we're just going nihilistic with everything around here. All the buildings shall be death. Why is it trying to take me? What the fuck is all this? This looks like if Dr. Seuss was in the cloud, what he would create. We're gonna talk to Mr. Horsey first. What can connect a user to an Amazon EC2 Linux instance through an SSH client? Instance ID, public IP address, metadata. Well, I doubt it's metadata, because that's just metadata. A public IP address. Probably there's some way to relate it back to it. Or an instance ID. You know, how non-user friendly Linux is and how back-end most of the commands are. At least the options for most of the command. I'm gonna have to go with instance ID as a guess. Incorrect. Sure, I'll try another question. Which type of deployment model is used in cloud computing? Cloud, partner, hybrid, on-premises. Deployment? I mean, you can have some on-premises. We're gonna go cloud, hybrid, and on-premises. Cool. Because partner doesn't really make sense. And Peanut. That's the dude. And now we're going to go up to this place. There's so many locations in the city. Networking Island. Yes. And we're leaving. Bye. Okay. Into somewhere else I've never been. Serverless Island. Ooh, the music got funky. What? Is this a polar bear? On Serverless Island? Are we gonna get questions about serverless then? No, not really. Which statement about the Amazon S3 data consistency model is correct? Alright. Amazon S3 provides read after write consistency for puts of new objects in an S3 bucket in all AWS regions. Amazon S3 provides strong read after write consistency for put and delete operations in all AWS regions. Amazon S3 offers eventual consistency for overwrite puts and deletes in all AWS regions. Okay, so first of all, Amazon S3 offers, Amazon S3 provides, Amazon S3 provides. I don't know what that means. But all of them are in all AWS regions, so we can kind of just ignore that text. So it's either read after write consistency for puts of new objects in an S3 bucket, strong read after write consistency for put and delete operations, or eventual consistency for overwrite puts and deletes. I'm gonna go with this one, and I have no idea why, because to be honest, I don't really know what an S3 put or delete is, other than like you're just putting something somewhere maybe. Can't think too much. Well done. You know, that was a lot of human engineering, just reading the question and thinking about the English of the words rather than what they actually meant in the test writers, which a lot of test taking is like that. is trying to get into the mind of the test taker, or the test writer as the test taker. All right, one more animal. Dang, this is a long road. Serverless is a big island. It's kind of bumpy too. Our camera's going goofy. This is our animal. So far away. Tiny little thing. What is this? It's a cat? It looks like an orange cat. Let me zoom in. Maybe a dog. No, it's a cat. Oh, what? Talk to the cat, you freak. A cat that wants to be my friends. And blah, blah. Question. Windows and Linux Amazon EC2 instances have free tier eligible instance types. Duh, true. Anything to make AWS sound better. Well done. Zazzy is becoming more friendly. Only one more question for Zazzy, and we get an orange cat. I only have one pet. How do I look at my pets again? I know that just came up, but no, that's my character. Pets. The gorilla is the picture for my pets. Why isn't it showing me the actual one pet that I have? Here's all the pets I could have. Why isn't it showing me the one fucking pet that I actually have? Okay, whatever. Alright, back to the phone. Databases in practice, connecting VPCs. Look, we just did something about VPCs. Let's keep those connections going. We also kind of did something with databases, but we're gonna go. Yeah. Some paper plane yoga. And serverless is a weird island. Why am I using the sidewalk? I've never seen a car. Never seen a car. I don't know how they did all this without cars. The sheer strength of paper airplanes. Why did it reroute me? This fucker's trying to get me killed. It's trying to send me to the... Oh. Man. Thought this boss battle was going to happen. This guy's definitely a young tech entrepreneur, startup dude with the hair like that. We're going to call him Alan. Let's see what Alan wants. Hi, I am the city's chief marketing officer. Of course you are. And this guy stole my... Oh, that's the same dude, huh? Yeah. I'll help you. But you know what? I'm not even going to listen to you. Fuck you. We're going to configure virtual private cloud peering between marketing and finance networks. All right. So let's get going. We're going to learn from our mistakes. As soon as we get into this little table, we're going to hit start. And then we don't have to wait. We don't have to wait our 3 minutes. This will give me time to go over the instructions. So, here's our AWS Cloud. Here's a virtual private cloud. Here's a virtual private cloud. Here's a virtual private cloud. We have our marketing VPC, finance VPC, and our developer VPC. Inside this VPC, we have an IP range. They're all different. We have an EC2 instance, so some type of computing, hosting a server. We have a routing table. That's what we learned last challenge. It's how to route traffic from these VPCs outward. Now, to get from one VPC to another, we need VPC peering connection. And this little image does a fine job at that. It's a little cloud. That's our VPC. And then some arrows, because we're going in those directions, connecting them all together. Implement VPC peering to enable communication between VPCs, allowing marketing and developer EC2 instances to access the financial services server in the finance VPC. So marketing has to get to finance. That's what we want, right? Oh no, developer also has to get to finance. So we're just allowing. All right. The VPCs are isolated by default. You have to use the VPC peering to connect them. Established through enabling the private IPv4 or IPv6 traffic routing between them. Hopefully IPv4 is easier to deal with. The route tables require new rules pointing to the VPC peering connection. So that's going to be our outbound, well, and inbound, I guess. We're going to do both. So this should be pretty similar to the last one. So we might have to create this whole VPC peering connection first before we do our routing tables. Thirty seconds. Man. What are we going to be doing? We're going to go to VPC. That makes sense. And then we're going to go to... We're going to be able to see that we have all these VPCs. Up, here we go. We're getting started. Let me make sure everything's running well like it should be. Hello. All right, cool. So, VPC. Okay, VPCs. Okay, here we go. Here's our VPCs. That seems pretty easy. Now we're going to go to EC2. And then we're going to look at our running instances. And then we're going to see all this shit. So EC2 running instances, and these are running instances. We have the marketing server, the finance server, and the developer server. So this one has a public IPv4 and a private IPv4. It's running, what else are we supposed to be looking at? No public IPv4 address is currently populated. They're all private. Oh, did I say public? What? No, this definitely has public. This one definitely has public. What about this one? All right. The finance server does not have a public one. And that's the developer one does. But it does have a private IPv4. An instance created in a private subnet has no public address. Under private IPv4 address, we're going to copy the private. We're going to use it later, so we're going to put it in our notes. So, I'm going to copy this. My favorite notepad in the world. A browser tab. Concept. A subnet represents a range of IP addresses within a VPC. Each subnet must be contained entirely within a single availability zone and cannot span across multiple availability zones. Good to know. You can connect to an Amazon Elastic Compute Cloud instance in 4 ways. EC2 Instance Connect, Session Manager, SSH Client, EC2 Serial Console. Did we skip a step? No. In the Instances section, clear the checkbox to deselect the Finance Server instance. Choose the Marketing Server instance and go to the Networking tab. And the Marketing Server instance belongs to something else. Okay, cool. So deselect this, selecting Marketing, Networking, and it has a VPC and it's in the Marketing VPC. All good stuff. All good stuff. Click Connect. All right, so these are the 4 ways we can connect. I just said that. EC2 Instance Connect, Session Manager, SSH Client, EC2 Serial Console. I'm guessing EC2 Instance Connect is probably the easiest way, and that's why it's first, and that's probably what we're going to be doing today. But let us see. No, Session Manager, and then Connect. So let's see what that looks like. Session Manager, Connect. And here we are in our Systems Manager console. Just says SHTAC 5.2. So we're in some sort of shell. And this is for our EC2 instance of the Finance Server, right? Marketing Server. So now we're going to ping the IP address that we copied earlier, right? So we're going to ping the Finance Server. Ping. It's probably not going to work. That's the whole point of this, right? It's going to time out. I don't see anything happening. There is no error alert because the Finances Server instances uses only private IP address. VPCs cannot establish routing paths to destinations outside of their local private IP ranges. To exit the running process, press Ctrl-C, go to the next step. So I'm gonna exit the ping. Boop. Sorry, that was not the right. There we go. 56 packets transmitted. Can we do ping tac C4 and have that work? Will that give me an error code? There's no way it's taking this long to ping 4 times. There we go. 4 packets transmitted, 0 received, 100% packet loss. No bueno. Marketing server. We're going to select the marketing server. And under the subnet ID, we're going to click on the subnet ID. So marketing server. Scroll down, subnet ID. Here we go. Now we're in the VPC console again. I remember this from the last one we did. In the subnet section, choose the available subnet name. Wait, what? On the details under route table, click the provided ID. So we're going to go to the subnets route table. Okay. And then routes. these are our routes. Do we edit routes again? Probably. Two routes should be displayed, one route for local traffic and one route for internet traffic through the internet gateway. Peering connections, that's actually what we're going to be doing. We're on this one. So let's look on the left, peering connections. Now we're going to make a peering connection. Create peering connection. Let's see if that works. Yep, that's what we're doing. Create a peering connection. Name it marketing to finance. I'm going to use these. Marketing. Finance. So we're going to choose the marketing VPC as the requester, and then confirm that it's 10.10.0.0/16. So marketing is the requester, and that's it. VPC ID is the acceptor, is going to be the finance. Okay, sorry. Oops. Okay, so this is the marketing, and this is finance. That's the acceptor. Cool. And that's a correct range. And then we're going to create it and make sure that it created. Create peering connection. A VPC peering connection has been requested. All right. We're going to look at the status, pending acceptance, and then we're going to click accept request. Why do we have to accept the request? Oh, okay. So because we made it from the marketing to the finance server, and we're on the, I don't know, accept request. Sure. I don't know why we had to do that if we're the ones requesting it in the first place. I don't understand that. Accepted it, and then we should see that it says active now. There we go, active. In the other browser tab, return to the instances page, and we're already there. Choose the marketing details, subnet ID. All right. Wait, we're not in marketing already? Marketing? Detail. Oh, did we do the wrong one first? No? We were supposed to be on marketing. Subnet ID. What? That's the same one, no? Am I tripping? Tripping. Okay. Choose the available subnet. On the route table, click the provided ID. Okay. What? choose the marketing route table. Okay. Edit routes. Oh, okay, we're doing something different. All right, cool. Edit routes. So we're gonna make a new destination. We're gonna do a peering connection. That's an option, huh? So add route. We're gonna add our destination and then a peering connection. And we should find one already because we made that peering connection. We just have to add the route to it now. This is making more sense. And then it should show up. So in our route tables, adding a route, pasting this, but instead of .5, we're going to go .0/24, of course. And we're going to do a peering connection. And this is the one we made earlier. So now it exists. Now we save it and we added it. It's good. Do we have to add this also, not just for the marketing, but do we have to add this to the finance too? It was marketing finance, right? This one? It was marketing finance, right? Okay, yeah, marketing finance. I'm guessing we have to add it to the route table of the finance. So let's go to public subnet 1 of the finance. It doesn't have a public subnet 1, does it? Oh, here it is. Public subnet 1. But the finance doesn't have a public subnet. So was it a private subnet that we used? Right? It was a private subnet, right? For finance? Return, go to the finance server, details, blah, blah, blah. There's only one available subnet. Click on subnet ID. Private subnet 1. Look at that. All right, so we're going to go to private subnet 1. I'm going to go to routes. I'm going to go to edit routes. We're going to add one. Oh, shit. I need to know the IP address of the other instance. So we're doing finance to marketing, right? So finance to marketing. We're going to... Fuck. We're using private, right? No, we're using public. We're using public for this guy. Right? We're using the public? We definitely use the public IP address for this guy, right? Oh my god, this is so annoying. Oh my god. Let me cheat. .10.10.0.16. 16? Why does that say 16, but then this says .18? Why? Oh, I'm retarded. That's the /16. Okay, so we're going to be using the private IPv4 address. Add a route, and we're gonna paste this, and instead of .18, we're gonna go .0/16, because that's our subnet. Peering connection, and we already created it. Let's add it and save the changes. Now it is routed to the peering connection that we created. Are we going to have to repeat these steps to connect the finance to the developers? So that one's done. Let's make sure that looks like that. I think that looks good. All right, I think that looks good. EC2, clear the checkbox. All right, so now we're gonna connect to the marketing server, session manager, and we're gonna try pinging again. So we're gonna take this. We're gonna make sure that the marketing can now ping finance. This should be the finance. So let's go back here, and we're going to ping this. .172.31.0.5. It's got to be right? It's got to be what we're doing. Still not working. Okay, so it's not supposed to work. Okay. Cool. All right, I was very confused for a second. So it's still not working. Control C. 100% packet loss. All right. Why though? Okay, well, we know it's still not working. Cool. There's a security thing in our finance server. A security group. Of course. Not only do we need a route table from VPC exiting from subnet to subnet, but we also need to get what's in that subnet, which is the EC2 instance. That EC2 instance has its own security group. Of course. So we're going to edit the inbound rules. Hopefully it has an outbound rule. We're going to add, let's go to it. We're going to, let's close these. I think we're done with these. So finance, security groups, outbound rules. It has one. It says anything can leave. I think that might be the default, but I'm not sure. Edit inbound rules. We're going to add a rule. And what are we going to add? ICMP. So that's ping, right? That's all we're going to add is just ICMP. Okay. And then from everybody, right? Anywhere? No, we're going to do 10.10.0.0.16. Sorry. 10.10.0.0/16. All right. Save that rule. Next step. And now we should be able to ping it because ICMP, that's what ping uses, is the Internet Control Message Protocol. So now this should work. There we go. Now, what is it going to ask me to do next? I could be proactive. So let's go to my instances. Details. This is what I was trying to ping, finance server. Am I going to try to ping it from the developer server now? Making sure that that works? I don't even know if my developer server has that how did we even get there? So we went details, subnet ID, peering connections. We only have one, marketing to finance. So we should create a peering connection from dev to finance. The requester is going to be developer, and the acceptor is going to be finance. And I think that's it. I think that's all we had to do there. So the peering connection is created. Now we have to check the route tables. We don't need to check the route tables of the peering connection. We need to check the route tables of how do we do this? Networking? No. What? Subnet ID? Did we? Route table here. There we go. So the developer, let's see our routes. We have one that goes to the I'm a little lost, so I'm going to stop what we're doing and I'm going to see what it has me do in the DIY. Configure VPC peering between developer and finance departments. All right, so that's what we're doing. We already got a head start. So VPC ID, is that how we did it? In our virtual private cloud console. No, that can't be it because I don't see the route tables anymore. So it wasn't the VPC console we were working with. It had to have been the subnet, right? Details, subnet ID, right? That had to be it. Because under security, we have our security groups, and then this has some rules. So we're inbound rules. Cancel. All right, so what's this guy's IP address? We need to add that to our finance server. We need to allow the ping. So networking subnet. Did we just try this? Did it not work? Route table. So it has one for this. Oh fuck. The peering connections, I need to accept it. Forgot about that. All right, so I accepted the dev finance. Now it's a good peering connection. So now let's go back to where we were at. Getting a little bit lost, but that's okay. These are our route tables. Filter routes. How do we edit the routes? man, this is tricky. Validate network connectivity between the developer and confirming that the... Oh, man. Oh, man. Okay, so take a deep breath. Let's get through this. Some good old-fashioned troubleshooting. So this exists. Add rule, add rule. So we need to get to the route table of the finance VPC and add that rule to allow it. All right, so finance VPC there's the route table. It wasn't any of these. I don't remember using any of these. Okay, we're in a route table. I don't know if it's the correct one, but we're in the route table of the finance, and we're allowing 17231. 17231. That's actually where we're at. That's weird. We want the 192.168.0020. Where is this? Oh my god, I'm getting so lost. Let's close this so we don't get confused. We're gonna add a route, and our destination is going to be 192.168.0020. And our target is going to be a peering connection between dev and finance. Save changes. Okay, that part is done. Here's our VPC. Now we need to go to the developer VPC and do the same thing. So here's our developer VPC, main route table. How do we scroll back? Sure. Okay. Edit routes, add one. But we're in dev. We need to go to 172.3.1. 172.3.1.0.0.16. Peering connection, dev and finance. Save changes. Now we didn't allow ping. And what did we allow ping on last time? It was a security group of, we're done with this. It was a security group of finance server, right? Security groups. Okay, it's allowing all ICMP v4. So from this source, which we just need to add another source. So we're going to edit this, and then we're going to add another source, which is going to be our 192.168.0.0/20. 192.168.0.0/20. We should have just added another rule, but we're just going to allow it from anywhere, which is kind of a cheat way to do this. Oh, it doesn't let us do that. It doesn't let us do that. So let's just add both of them back. 192.168.0.020. 192.168. .0.0/20. I'm gonna add a new rule, ICMP, and this was 10.10.0.0/16, right? Let's see if that was right. Yeah, I've only done it like 50 times already today. Cool. Save our rules. Oh my God, what? Oh shit. This has got to be ICMP, right? What? Oh, okay. Now let's try it. What? Retry? Cancel? Okay, so I can't do the ping. I don't know why this is allowed. But it won't let me add another one. So this is allowed. All from this range. And we're just gonna add another range, which is 192.168.0.0.20. 192.168.0.0.20. And it looks the exact same, so it should let us save it. What did I do wrong? Okay. Either way, I think we're good to go. So the developer instance ID, I don't even think we had to do the ping. So here's our developer instance ID. I'm gonna copy that. Boom. And our finance. Gonna copy that. Then we're gonna validate. And it's gonna work because after this, well, I did it. Let's go. Check that out. We're learning. Dude, VPC plus 10. And then routing plus 10. I don't know what they're going to say. Networking plus 10? Probably VPC and networking, right? No, thank you. All right, push-ups. Ah. Ah. Alrighty. Let's see what we got going on. Come on, Alan. What you gotta say to me? What are you gonna give me? Excellent job. Choose reward. We got it doesn't even say what this fucking building. Oh, he probably said it in the beginning when I skipped all this bullshit. Alright, we're gonna go medieval, of course. That spike looks pretty fucking cool, but you can't beat a castle and a bunch of wooden bullshit, right? Boom! Wow. Whatever this is, good luck with it. Congratulations. Plus 10 VPC, plus 10 EC2, plus 10 VPC? I don't know. Anyways, that's where we'll end things today. Did 3 more beautiful lessons. Thank you guys for staying tuned and learning. I'll catch you guys in the next episode. We're still cramming for this test. We're still gonna make it happen. We're gonna do the impossible, and I'm gonna get things I shouldn't because I'm too stubborn to say that I can't do it. And you guys should do the same.